So basically, it's actually pretty much set up for ready for them to go, or ready for it to go. The only thing that they actually have to do is add these right here, which are the isotenoscopes. And actually, that one looks like it's missing a piece. That one's missing the tubing, so I'll have to worry about that later. So what they'll do is they'll just grab these and they'll grab the clamps, which are right here. And this will be clamped like so. Here's just a little ball joint, and then just clamped on right there. And then these will connect to the condenser, which is down in the water bath down there. And they're just quick connects. And they're obviously one direction, so. Linear, so I think free translational. Should have been better than that. No, worry about that later. Okay. And so actually, so this setup is pretty much done except for that. Okay, so we'll plug these in. Turn this on. Okay, so you hear the pumps on. You can see the water pump is on down there. So we can see water flowing through the condenser. Okay, we have our pressure gauge, which is connected here. Thermocouple in the water bath. And this controls the heating element. So you can turn that on. And right now it's set pretty low. Turn that up and you can see the heating element start. So this is the heating element. This is, you'll just start to see it turn kind of red to heat the water. Let's see. Yeah, it's slowly starting to glow. Okay, so this lab has a couple of pretty tricky elements. One very specific one, and it's going to be them controlling the pressure in the system. So this is the unknown. Okay, so that means the other one should be toluene. So there's toluene and unknown. The unknown is isopropanol. So just to give you a heads up. That's pretty easy. What they're going to do here is they're actually just going to be decreasing the pressure to measure the what would effectively be the vapor pressure of the sample at different temperatures. Okay, so right now you can see how it's heating up right there. And you can see it slowly starting to increase. Okay, so we'll let it keep going for a few minutes, but what they're going to do right here is they're going to use this valve to control the pressure of the system. And so this valve has a two-way open. So there's one valve here and one valve in the back. So in this direction you can see the front valve right here is connected to this port, which is connected to atmosphere. And so this is reading atmospheric pressure. Then if you turn it the opposite direction, you can see the back one will open to the back port, which will open to the vacuum. And so you can actually hear the difference. So and see it right there. So now we have the system under vacuum. And so now we can also see down here, that's pulling the air out of the bubble. So I'll show you what I mean. So you can see in this system right here, on the left-hand side, there's a fair amount of air. So they actually have to pull all of this air out before they could get their system running. And so that's what's going to be happening right now. So we'll put it back under vacuum. And it's going to pull all the air out of the system. One of the real tricks here is when they open this to the vacuum, they just want to have it barely open. If they open it too much, it's going to be too hard of a vacuum, and it could actually boil their substance off. Or if nothing else, you actually start to see it collect in here, which is a bad thing. And so now you can see it's actually starting to get closer to boiling as the bubbles change their... You know, before it was kind of a nice, consistent bubbling. Now it's more of a boiling. And so you can definitely tell it's boiling as the level starts to increase. So what's going to happen here, as the pressure decreases, on the right hand side that level is going to increase and it's vaporizing, so it's boiling off. And so effectively what we're measuring is the pressure that it boils at, or the relationship between the pressure and the temperature. So at 25 degrees, if you decrease it down to 70 torr, it's going to be boiling. That's pretty much what we're collecting. So let's see.
Whatever the heavier one we have a little. So we're going to get the doublets.
You can see it's getting kind of vigorous, so it's really starting to get
basically assuming
towards its boiling point. And so what they want to do once they get to this is they want to be careful, and they don't want it to start getting too high into here. So that's why there's a condenser, so that it should ideally push it back down. You can see how it's getting vigorous here. They want to avoid that because they don't want it to get all the way up. So what they're going to do, once it gets to something like that, is then they're going to go and reintroduce air. So they're going to have to push this the other way. But they again want to be careful and just open it a little bit, because if they push too much air, air is going to force its way all the way into the system. And then they got to re-evacuate it. So what they'll notice when they open it slightly to air is they'll see the boiling stop. And this is going to take a very fine control by them and their partner. So you can see it boiling at, well, it almost stopped.
So they take the fundamental HCl spectrum and then the overtone. So the fundamental is... Yeah, so the spectrum is due to the transition of the molecule from ground vibrational state to...
There we go.
First excited vibration
okay.
state.
And so what you can actually see happening here... Went higher than I kind of wanted to.
There's like B double...
Okay, so you can actually see happening here, it's kind of evened out a little bit. Okay. What they want now is they want the levels in the two sides to be equal.
Anyway,
so
this is from the overtone, and the spectrum splits.
Right now we can see this side is kind of low and this side is high. So what they're going to do is they're going to reintroduce air to push this down so that these two are going to be equal. So if I open this back to the air very carefully, and again, this is where we're definitely going to have to be careful. You can see it'll push the right hand side down and the middle one is going to go up.
Yeah.
And so what they want is they want the two levels to be equal. When those two levels are equal and the temperature is constant, then they're going to take a data point. They'll take that pressure and they'll take that temperature. So what we're going to try and do is we're going to try and have them take temperatures from 30 to 70 in 5-degree increments, and then back down from 70 to 30 in 5-degree increments, just so they have both sides of it. And then we'll see what they can do to compare the data. I don't know. I mean, you can't really make an error with 2 points. And you can actually see it's still not equal, so they might actually have to kind of get down to get a eye level with it. So let's see if I can even it out a little bit more. Oops. So you can actually see what I just did. I actually pushed it too far on the right-hand side. And they have to be careful there. If they push that all the way down, then air is going to be back in the system. If they push it too far down, then they got to open it back to the vacuum and have the vacuum pull it back up. So this is where controlling this becomes crucial. So open it to the vacuum just a little bit and get them close to even. And so now you can see that they're pretty much even. So ideally, if this was at 30 degrees, then we would have our 30 degrees, our pressure, and then they could take that point. And so, let's see. Turn this up a little bit more. Normally I tell them to get close, maybe about within 0.5 of the temperature, so 29.5 to 30.5, something like that. That way it's relatively consistent, but it doesn't have to be 30.0, because obviously the pressure and temperature are dependent on each other. So, if it's 30.1, then the pressure is going to be different than if it was 29.8. So it's not as crucial to be right on the number, as long as they get this as close as possible. Plus, also, there's no like points for accuracy. Okay, so once they get that set up and they get their temperature, or they get their reading at 30, then turn the heater back on, and they'll heat it up to their next point, 35. What they're going to want to do when they do that, though, is keep an eye at that level. That level is going to change as the temperature changes, so they're going to have to change this accordingly. So if that's dropping, then they're going to have to open the vacuum to pull it back up. If it's coming up too high, then they're going to have to add air to push it back down. So as the temperature changes, they're going to have to keep an eye on this just to make sure that either air doesn't go back in or it doesn't boil off. Okay, so the most important part is making sure it doesn't boil. Because if it boils and we get any sample up in here, then that's pretty much going to kill their lab. Because we don't have anything to clean that out with. And if this is all boiled out, then we have to get Chris to refill it. During the day, that's not as much of a problem. At the night labs, he's not here. So, there's no solution. So that's pretty much what all they're going to do. They're going to go from 30 to 70, and then back down from 70 to 30. Take data points at each one. In the end, once they're all said and done, then they could just put it back, well, they can turn off the heater and put it back under air. So they could, well, I don't want to introduce it that fast. We can get it back to room pressure. If they have enough time, they might be able to run both in one day. So the unknown and the standard. That depends on how good they are at it. They may be able to, they might not. One thing to keep in mind, when they're doing the cooling down from 70 to 30, they'll want to use some ice to help cool this down. That way it goes a little bit faster. We had an ice bucket. Well, we'll dig that back up at some point. That way they could just go down the hall and grab some ice. And there should be some beakers somewhere, so that as they're adding ice, obviously this is going to keep going up. They might have to pull water out over time. We got a drain there, so not a big problem. Oh, looks like room. Okay. And so once that's all done, then they can, let's see what's the best way. We'll turn this off. They should disconnect the top one first. And then the bottom one. And then they'll just pull this off. Please make sure they're careful. Little waters and everything. Please make sure they're careful with these, because if one breaks, we probably won't be able to replace it this quarter. Last time we had one break and that was it. So once it's done, they can put it back up here. And then if they have time, they can do the other one. If not, they can do the other one the next day.